Hello and good morning, everyone. We're going to work a little bit here on going over the answers to your summative review on functions. So hopefully this is really helpful for you to make sure that you understand. So when we have a list of points, okay, domain is always just a set of possible x values. Range is just the set of possible y values. What is in that group? When we just have a list of points, we're not going all the way from, let's say, -3 all the way up to 5. So if I write it like this, there's a problem because it doesn't account for what about 2.5 and 2.4 and 2.3. It's not all those points in between, right? It's not every single point between -3 and 5. What we're looking for here, what's actually in the domain, are these x values. -3 is one of them, so I'll include that. -1 is one of them. 0 is in there. 3 is in there. And 5 is in there, right? That is my domain. Not all the things that are in between there. I wanted to make sure that that was highlighted and that you understood that. Range is the same thing, possible y values. So I could have -2. Look, -2 again, but I've already got that. I've already said that that's a possible output, so I don't need to list it again. Here's -1, and then I've got 3 and 9. These are the possible outputs. So I've got possible inputs, possible outputs. And to be a function, I just need to make sure that each input has only one output. Every time I hit that button for the input, does the same thing come out? It's not a function if sometimes I hit the button and I get one output, and sometimes I hit the same button and I get a different output. That makes it not a function. But here, each input, the input of -3 has only one output. -1 has only one, 0 has only one, 3 has only one, and 5 has only one. So this is a function, yes, and I would say because each input has only one output, and that's what you would write for each of these, which I'm not going to repeat every single problem, but that's what you would write for all these. Okay, here, domain for number 2. Domain, okay, number -2 is in the domain. -4 is in the domain. I probably should have put that first. 1 is in the domain, and 6 is in the domain. That's my list. Now the range is my y values. It looks like my smallest y value is -1. Then I have -3. Then I have 5, and I have 8. Now, does every input have only one output? I'm going to start with -4. -4 has only one output of 8, so that's okay. How about -2? -2 has an output of -3. Oh, but -2 also has an output of 5. So sometimes I put -2 in and I get out -3. Other times I put -2 in and I get out 5. That's a problem. That's not functioning properly. That's not a function. And because we would write the input of -2 has two different outputs. Okay, number 3, domain, my set of all my inputs, right? So that's -1, -2, -7, and 2. I'd like them to be in order, but I didn't do it that time. That's not a huge deal. Range, be 0, -5 actually is my smallest, then -4, then 0, 4, and 5. Okay, is it a function? I'm going to look at my inputs and see, does every input have only one output? -1 has only one. How about -2? That has only one. How about -7? Aha, here we have a -7 output of 5 and a -7 output of -4. So this is not a function because the input of -7 has two different outputs. Number 4, domain would be 0, 5, 10, 15, and 20. My range looks like my smallest one is 10, and then I've got a 20, and I've got a 30. Does every input have only one output? 0 has only one, 5 has only one, 10 has only one, 15 has only one, 20 has only one. So yes, each input has only one output. All right, section The next section is problem 5, where we got a bunch of different functions here. We've got an f function, g function, h function, k function, p function. And it's asking, in the f function, when the input is 4, what is my output? So I'm just going to go here, and I'm going to plug in, oh, here, now we can see it. I'm going to go here, and I'm going to plug 4 into the f function. So f of 4 would be putting 4 in for x, and that equals 10. So f of 4 is equal to 10. G of 3. Well, if I go 3 squared, that's 9. 9 minus 1 would be 8. So G of 3 is 8. H of negative 4. In the h function, if I plug in negative 4, that's 3 times negative 4 plus 4. That's negative 12 plus 4. That's negative 8. So I could say h of negative 4 equals negative 8. P of negative 9. Aha, now this is an opposite sign of whatever x is. So I'm going to have like negative 1 times negative 9, which is positive 9. So P of negative 9 is positive 9. K of negative 1, I'm going to plug in negative 1 into the k function, which is here. So that's 2 times negative 1 squared minus 4 times negative 1 plus 1. Now I know negative 1 squared. My calculator will tell me differently, but I know a negative times a negative is a positive. So that's 1 times 2 is 2. 4 times 1 is 4. There we go. So that is 9. So k of negative 1 equals 9. P of 2. Aha, so I'm just plugging in negative 1 times a 2. That equals negative 2. P of 2 equals negative 2. G of negative 5, I'm going back to the g function. I'm going to put negative 5 there. And I know that when we square a negative, it actually becomes positive 25. That's 24. So G of negative 5 equals 24. Now over here, it's a little different because now it's asking, what is my input if my output is negative 5? And all I'm going to do here is I'm going to replace the f of x with negative 5. So I'm going to put negative 5 equals x plus 6. And then figure out what would that input be. Well, I could just subtract 6 from both sides. That's negative 11. So when the input is negative 11, my output is negative 5. F of negative 11 equals negative 5. Here, what is x? If h of x is 28. So if I put all that instead of h of x, I'm going to set this equation. Solve my equation. Subtracting 4, divide by 3, I get 8. So that means my input in the h function is 8 when the output is 28. What is the input when the output in the p function is 17? I'll put 17 in for p of x. 17 equals negative x. So I guess if negative x is positive 17, then positive x is negative 17. So p of negative 17 is equal to positive 17. What is x if g of x is 3? So I'll put 3 in all the way up here for g of x. We'll come all the way down here. And we got 3 is equal to x squared minus 1. I'm going to add 1 to both sides. And I get x squared is 10. So I'll take the square root of both sides, and I can leave that as just square root of 10 is okay. So I know that g of square root of 10 is equal to 3. Okay, there's our video. Remember on the ones here, I'm just going to really quickly talk about these. Remember, we look for the vertical line test to see if it's a function. If it hits 2 points, it's not a function. Not a function, is a function, is a function, is a function, not a function, not a function. Those are things that we want to be careful about. Domain, we just say, what are the x values? Well, this goes from 2 and up. So x is got to be greater than or equal to 2. Range, it goes all the way up, all the way down. We can say all reals. This is the symbol for all reals. This one's going to go all the way left, all the way right, all the way up, all the way down. So all reals, and all reals. Domain here from 0 and to the right, so we'll say greater than 0. The range is going to be everything below 2. So y is less than or equal to 2. Domain here is everything less than x, but not equal to, or less than 2, but not equal to it. So I'm going to say less than 2, but I'm not going to put that equal sign on there because it's not equal to it. Range is everything below 3, but not equal to it. So there we go. Domain here, 1, 2, 3, everything to the left of 3, except for it doesn't go all the way down. It stops here at, looks like, -1, maybe -2. Let's call that -2. So let's say -2 between there and 3, except for on this side it actually hits it, so we'll make it equal to it. On this side it's open, so it's not equal to. The range, the bottom here is -2, the top here is 1, 2, 3, 4. So I'm going to say from there all the way up to 4. This one is not included because it's open circle. This one is included because it's a closed circle. Domain here, we're just counting points, right? Just like on the front. 1, 2, 3, 4. So -4, -2, 0, 2, and 4. And my ranges looks like -4 and -2 and 0, 3, 4, 5. Last questions, domain and range here. Well, this is going to make a line. So I think about it and say, are there any big positive numbers that can't go in here? I could put a positive number in there like 100. That would make -200 plus 7. It'd be something weird, but it'd still be possible. I could put in 0. I could also put in negative numbers. So really anything is possible. We would say all reals, right? Domain and range here, though, we never want the bottom of a fraction to be 0. So if x was -2, that would be -2 plus 2, which makes it 0. That would be a problem. So we'd say x can be anything except for x cannot equal -2. Anything else would be fine, just not -2. Hope that makes some sense.